Okay, graphing logarithms. So when we went through domain in this course, we kind of talked about three cases. We did fractions, we did square roots, and we did everything else essentially, right? And if we could identify which category our function falls into, we did a process. But the kind of nicest of the processes was the third one of, oh, great, I don't have a fraction, I don't have a square root. So my answer is all real numbers. But I also mentioned at the time that that's not true, that those categories will work for the majority of this class. This is where it starts to break down just a little bit. It's a small change, it's a small wrinkle. And that's with logarithms. If I just sketch a quick graph of what a logarithmic graph looks like. Generally, without transformation, they look like this. It kind of makes sense. What I'm doing here is, or this, what this looks like is, if I took an exponential graph and kind of turned it, or I guess more likely flipped it and turned it a little bit. And so you can notice with this graph that it actually looks like, oh, I don't really ever cross the y-axis, and that's true of a very basic log graph, like let's say this is log 2 of x. And so this is the wrinkle in that kind of breakdown of domain, is when we have a logarithm, we do a very similar process to what we did with square roots. So if this was a 1 minus 2x square rooted, well, the process to find that domain is I set this greater than or equal to 0, solve, and then write it in the interval notation. Now, if we're doing logarithms, the process is I take whatever is inside my log or my ln or my log base b, doesn't really matter what the base is, and then I set that greater than, just greater than 0, not greater than or equal to. So almost the exact same thing as a square root. The small change here is it's not greater than or equal to. And then every other step of the process is the same. I solve for x, divide both sides by 2. So how do I write this answer in interval notation? It helps to have a math environment. Trying to write the 1/2 is greater than x, or x is less than 1/2. It's probably a better way to read it. Oh, good thing we're doing this. We're reviewing our interval notation. So if x is less than 1/2, what's the smallest value x can be? Oh, wow. What's the biggest value x can be? Is my microphone working? Uh-oh. Okay, so good, my microphone's working. Yes, Austin, x is everything less than 1/2. So what's the smallest value x can be? Or again, what's the biggest value? I'll take either side of that question.
Would it be 1/2?
That's the biggest value, great. So I'll do a parentheses, allowance, that in. Parentheses, something, comma, 1/2. This is a shape weird. Okay, So that's the biggest value. What's the smallest value? Oh, answer that.
Negative infinity.
Yeah, perfect. And so Austin asks a very good question in the chat. If it's everything less than 1/2, well, x can't be 1/2. So shouldn't we say 0.4999999 on forever and ever? Well, what this parenthesis says is accounting for that. If I have a parentheses on the number, I'm saying it's going to go up to that number, get as close as possible, but it's not actually going to touch. So if this was a bracket, then yeah, that would be wrong, right? Because we can't actually get up to 1/2. But this parentheses is taking care of exactly what you're saying, exactly that issue of we're never getting to 1/2, we're getting really close, but it has to be less than 1/2. So that's the parentheses. When we are dealing with square roots, we use brackets as parentheses. Cool. Any questions about that? No, you're good. A lot of people do that, and it makes sense. I would and have thought that the same. So the same thought, that same thought. There we go. Okay. Moving on. I'm going to leave that graph up to the left and erase that domain. Okay, so here I want to find my domain, find my vertical asymptote, find my intercepts. I might kind of skip this guy, so let's put them in italics. I will talk about him briefly though. And I want to behavior too. Let's skip that part. So at the end of the day, what I really want to do for this question is graph. And if I can identify my vertical asymptotes, and if I can identify my 3 key points or 2 key points, what we do with logarithms, then it's really just kind of connect the dots again and I'll be good to go. So with this log graph 2 over here that we see, let's give them some properties. Let's actually make it a little bit more generic. Let's not do a log base 2. Let's say I don't know what this log is over here. I'm just going to say it's b. Could be anything. Well, any positive number. Could be 1, could be 1,000, could be 2. That's perfectly fine. But the properties I'm about to give you are the same for any log base of a graph. So let's insert an equation. So for starters, what's the domain of that graph to the right, or the domain of any logarithm before I've applied any shifts or anything like that? Guess are fine as well. If you make a guess and it's wrong, that's perfectly fine. I make wrong guesses.
0 to infinity.
All right. And we can do that in 2 ways, or see that in 2 ways. One, well, we can just look at the graph. It's not that much of a stretch to see that's 0 to infinity, but also we can use this process that if I have just a generic log base b of x graph, I find the domain by setting the inside, which is just a single x, greater than 0. Boom, there's my domain. Okay. Now finding my horizontal asymptote is fairly simple as well. I mean, simple is always a dangerous term in mathematics, but finding my horizontal asymptote is always going to kind of be where my graph is cut off. So we can see in this graph that I have these kind of dashes that give away what the horizontal asymptote is, but it's showing me if I have my domain, it's where my domain starts or where my domain ends. So to identify my horizontal asymptote, I always look at my domain and say, okay, what's the number in my domain? 0. Oh, sorry, not y, x. Which makes sense. I mean, your horizontal asymptote can't be infinity, and that 0 is where your graph starts or where it ends. So like on this one, what's my horizontal asymptote of this function? So vertical asymptote, vertical asymptote. It helps to look at the domain.
X equals 1/2.
Perfect. Yep. Just look at the number. That's going to be your vertical asymptote. Okay. So I should label this. Vertical asymptote, once you found the domain, vertical asymptote is very little work. It's kind of like when we were doing our axis of symmetry, that once we found our vertex, the axis of symmetry was just the X value. When we're finding our vertical asymptote, it's just always going to be the number value of our domain. Okay, and then our key points. We usually only use 2 key points, but we can label 3. And since this is a generic log graph, do you want to maybe put this over here so we realize what I'm talking about? Since this is a generic log graph that I don't know my base, my key points will kind of have to rotate around that fact. So 1 key point of every logarithmic graph before transformation is 1, 0. Which makes sense. Anytime I plug in 1 into a logarithm, I get back the value of 0. Cool. Another key point, B, which it depends on my base. So if my base is, if I have a log base 2 of X, it would be 2. If I have a log base 7 of X, it would be 7. If I plug in B into my generic logarithm, what should be the value I get back?
Is it 2?
Close.
Is it -2?
Less close. If I have a log and I have my base and I plug in my base into my log, that equals blank. It's a log property.
1.
1. And then if I really want a 3rd key point, we usually don't do this because sometimes the b² is very hard to track down or very hard to evaluate. But if we want to, the 3rd key point we can get is b² is 2. So as an example, if we said this was a log base 3, then my 3 key points would be 1, 0, 3, 1, and then, well, 3 squared is 9, so 9, 2. So usually we have actual values once we know what the base of our graph is, but these were just kind of for any base. Okay. Any questions about that before we graph this guy? Okay, well, let's start by finding my domain. Ooh. What is my domain / how do I find my domain?
You take the x - 1 and set it greater than 0.
Perfect. Which then becomes a 1-step process. I find x is greater than 1. So what's my domain? In interval notation, I mean, technically what I just said is my domain. But what's my
1 to
domain?
infinity.
Yep. Okay, what's my vertical asymptote?
X equals 1.
Perfect. Yep. And that should be very little work. I would argue domain can be a little bit tricky because it's a bit of a process. But my vertical asymptote, I just look at my domain, boom, 1, cool, call it a day. Okay, my key points for this graph, well, this is my parent function is log base 2. So my 2 key points are going to be, just use a text box, I suppose. Oh no, I want to use an equation. Are going to be 1, 0. That's always going to be, I'm just going 1, 0, and then B in this case is 2. So 2 from 1. What are the transformations happening to my log function? Right, because outside of identifying my vertical asymptote and outside of identifying my key points, which I just told you what that is over here, this process is something we've seen twice, maybe 3 times at this point of now I identify my transformations, I apply them to my key points, and then I should be able to graph. So if my parent function is this log base 2 of x, what transformations are happening? Yes, we have to follow order of operation. So certainly the first in the chat, Austin said, up 3, right 1. I will say right 1 is the first thing because that's inside my parentheses. So that will be my first transformation. Up 3 is one of them, but there's another one that happens before that.
You move right 1. Oh, wait. And then you do the left one?
You move right 1, but and we do also move up 3, but we're missing one transformation.
It's reflected, isn't it?
Yeah. Do vertically reflected, or if you want to get fancy, say that it's reflected over the x-axis, or really what we're going to do is multiply our y value by -1. What's in the parentheses is probably the least technical of statements, but it also shows me you know what that is actually doing to my key points. And now we can say up 3. Order matters, so it seems silly that I'm being very particular of, okay, we can't write up 3 first and then vertically reflect, but yeah, we do have to follow the parentheses, then multiplication, then addition. Okay, back to my key points. How do I move these points right 1?
You'd add 1 to every x value.
Mm-hmm. And if you're having problems remembering of, okay, I see that transformation, but I forget if right is applied to x or y, think about that inside outside. The right one is inside my function, so it's going to be doing stuff to my x values. The -1 and the 3 is outside the function, so it's going to be doing stuff to my y values. Okay? How do I do my reflection? Well, I actually gave it to you, so I'm not going to ask that question. So for my reflection, I multiply my y values by -1. It's actually not going to change my first point, oddly enough, because my y value is 0. It's going to change my second point to 3, -2. Okay, how do I apply my last transformation?
You'd add 3 to your y values.
Okay. Now I can finally graph this, putting together all of my pieces. So I have my parent function on the right. Maybe I should delete them to get more space, but I think I have enough here.
I just have a quick, why is it 3, -2? Wouldn't it just be 3, -1 for a point?
Thank you. Okay, so I know my horizontal vertical asymptote is at x is equal to 1. So that's my vertical asymptote. I plot my 2 key points. So 2, 0. I'm drawing with a mouse, so it's never good. 3, 1. And now based on the swoop that I see up here, I know that my graph is either going to, I vertically reflected it. Did I do that right? 3, 1, 2, 3. I am crushing it today. I guess that'll give a good example of what I'm about to say. Okay, so I have my 2 key points. I know my general shape is this swoosh. And so, well, I can either try and say, okay, I'm going to swoosh exactly like I have up there. Okay, I wasn't able to go through both points. Let me try that again. Okay, well, I'm able to do this one. I'm still stuck. So even though it's a swoosh, it doesn't specifically have to be facing the same direction. And so I'm going to, in order to connect the dots, have to go into the opposite direction. And yeah, that, I guess, kind of fortunate mistake for you guys. What I did there, the mistake I made, is that I didn't plot this point correctly. Makes sense. There's a lot of stuff going around. There's a lot of move. Oh, sorry. I even guessed what point I was plotting wrong. A lot of mistakes, a lot of places to have an error. But now I looked back at my transformations, and originally my point was going to have this swoosh go in the opposite direction of what it's actually happening now. Yeah, Austin's right. 3, 2, not 3, 1. Let's see, 2, 1, right 1, multiplied by -1, up 3. Oh boy. Yep. Even more mistake. Not how to fix though. Okay, there we go. Same general shape, just off by direction. Thanks, Austin. Yeah, so anyways, what I was saying is that a good way to check to say if your answer makes a little bit of sense is going to say, okay, let's look back at my transformation. Is my graph being shifted right 1? Okay, it definitely looks like that. I have my new horizontal asymptote. It is to the right. Is my graph moving up 3? That's not the easiest thing to see because we've already flipped it, and the shape of a graph or a log graph is a little bit, swoopy as opposed to a strict line, but I would say that's arguably, that makes sense. I see my points being moved up. And then the thing that helped me catch my error was really this of my graph was reflected. So it should not have the same direction as the graph that I had there. So make sure you're running kind of those quick checks when you draw your final graph of, okay, I have my 2 key points. I drew my graph. Does it actually match with those or the transformations I actually wrote? Don't we do b squared too? Yes. Oh, Jackie's saying we don't do it. Yeah, so we can have 3 key points if we want to. And in fact, for a log base 2, it's not that difficult, right? 2 squared is equal to 4, so why not do 4 too? It gets a little bit tricky when we're dealing with like an ln, because e squared is very hard to understand conceptually. Like I don't know what that number is quickly off the top of my head. Could give you an okay estimate, but I wouldn't be that great at it. And same thing, like if I have just a log, like standard log, so a log base 10, well then that b squared is 100. So that's going to be hard to graph on my graph, right? Like that key point would be all the way, honestly, even more over here. So you can use it if you want to, especially if it's a small base, like a 2 or a 3, not that difficult to do. So like, why not do it? We typically don't do it in general for log graphs for that reason, but that's a great question of depending on our log, if it's a larger or even slightly larger base, like log base 5, that's kind of going to be hard to graph 25 to. So we stick to mostly the 2 points, but yeah, you can include that if you want to. And then Courtney's saying, can I explain the key points again? So the key points I wrote here were generally for just a log base that I don't know. Like I said, in general, these are always going to be my key points. 1, 0, b1, b squared 2. Once I know my base, I can actually figure out my key points in like a concrete matter, right? Like if it's a log base, let's say 3 of x. Once I know my base, okay, my base is 3. So the key points of the log base 3 graph will be 3, 1 and 3 squared 2. If it is a log base 15 graph, we won't do that, but you could potentially do that, be capable of doing that. If it's log base 15, well, then this b is 15, this b is 15. So I just wrote my key points to work for any base, but you do have to do the little bit of additional step of, okay, once I actually know my base, I'm just going to throw in whatever B is into my key points. That makes sense? A lot of good questions. Cool. I'll assume that makes sense. Yep, no problem. Any other questions? A lot of moving pieces here. Log graphs aren't the easiest thing in the world. Cool. Now, surprise, surprise, what we love to do in mathematics is we like to say, okay, maybe you have a small grasp of what, how to graph something if we give you an equation. Are you able to do the reverse? Are we able to take a graph and find my equation? And so what I should do, and what any good question will give you, is say, okay, my parent function of this graph is going to be, in this case, it's, well, I want to write it as an equation, so. Log base 2. Right, because otherwise you're going to have to guess a little bit and say, I don't know. Yeah, I guess like there isn't a technical way to do it, but it's that general shape. Like a logarithmic graph is always going to have a swoop like what we see here, or maybe a swoop in the opposite direction. So it's just kind of like any that's a terrible picture. It's like any graph of, if you can tell the picture, it's going to have a very specific shape of that, or maybe, you know, it's going in the opposite direction, but it's going to have that swoop with, if I have like an exponential, I have that swoop like this. So it looks a lot like an exponential, just kind of turn. That's how you kind of identify it. As far as what the specific base is, that becomes a bit more of a battle. That's not worth discussing in this course, and honestly, not worth discussing in a whole lot of mathematics courses. Oh, I erased the fact that this is my parent function. Oh, tell me things about this graph. Or guess about things about this graph. And it doesn't really have to necessarily be related to logs, just any observation you can see about it.
It has a vertical asymptote at 1.
Perfect.
X
Yep.
at 1.
Yeah. And you know, that might be if you're on the final exam and you're concerned of, is that exactly right? That's not a bad question to ask me in the room and say, okay, in the Zoom room I'll be sitting in, is, I think, can I say the vertical asymptote is at this point? And I'll say yes or no. I'm not going to, if you ask me what is the vertical asymptote, I won't give you that, but I will answer a clarifying question like that. So perfect, yes, my vertical asymptote in this case is indeed x is equal to 1. What else?
If your vertical asymptote is x is 1, then your domain is 1 to positive infinity.
What else? What about points? Are there any points that seem to be on our graph?
Yeah, there's points at 5, 4, and 3, 3.
5, 4, and 3, 3. Agreed. I can't make the assumption that these are key points. Maybe, probably, they are key points, but even if I were able to comfortably say that, I don't know if they're specifically like the 1, 0 point or the B1 point. All I can say that these are points on my graph. And again, very good question to ask if you say, I think it's at 3, 3, but I'm not sure. pop in the room, shoot me an email, and I'll be like, yep, you're right in thinking that, or it's close, but maybe look elsewhere. Okay, and I think that's it. I mean, obviously it's a log graph. I don't think that's a terrible assumption to say from that. I will mention as well that in this question, outside of this course, you could be asked to find a graph that has stretches and shrinks. We're going to say right that now that there aren't any of those, because that also is another battle that's unnecessarily difficult. So with that in mind, I know my parent function is log base 2 of x. And so for starters, if I know my graph has a log base 2 of x, if I know my graph has a vertical asymptote of x is equal to 1, what is that going to do to my function? Or what does that tell me about my function? What transformation is going to happen there? Oh, click on, click off. It's going to be a translation as a hint, because we said it's no stretches and shrinks, and the fact that I have a vertical asymptote doesn't really care about reflections.
Is it -1?
Perfect. Yep. And why did you say -1?
Because your vertical asymptote is 1, and then when finding the domain, if you set it equal to 0, you would find that it would be 1. And so it'd be the opposite.
Perfect. Reverse engineering. I love it. That's one way of doing it. The other is too, since your graph is normally at, or your vertical asymptote is normally at 0, well, it's getting shifted right 1. So -1 inside my function. But I like your answer, honestly, a little bit more than that. It's kind of nice to, or clever to go back and say, okay, my domain is this, so why not just build what should be inside my function? Great. And I don't know what my vertical shift is, if there's one. Maybe k is 0 and we're done. That's not the case here, but that can happen. So we're going to have a horizontal shift, which we accounted for. We have no stretches and shrinks. My graph isn't being reflected at all. That's kind of the standard log graph right there. But I don't know my vertical shift. So any thoughts about how I might find that k? This is a strategy that we saw when we were solving for vertex form. This is a strategy that we saw when we were solving for y is equal to mx plus b. This is a strategy we do anytime we have a graph. Well, not anytime. Most of the times when we have a graph and we're trying to solve for an unknown. There's something we can use. There's some piece of information above my function that I haven't used yet. Okay, maybe I'll steer it a little bit more. How can I use this information? No ideas. Give me some, Austin.
You just take the key points from the parent function and just compare them to like the points that you've listed there, no? And the difference between the y coordinates would be, the difference between them would be like
So what you're
that's-
saying is kind of globally true, right? Like that's the the
Yeah, that's a
broad
horrible way to explain it.
No, it's not horrible, but that's the broad picture. Piper actually kind of made your explanation concise. What Piper is saying in the chat, plug in the points, solve for K. But that's, like I said, that's kind of vaguely what Austin is getting at, I think. I don't know. I guess maybe I might be reading that incorrectly.
No,
So-
it was. It's just I worded that horribly. I wasn't sure how to word it. So
No, you're good. I appreciate breaking the silence at the very least. Seems like we got a quiet crowd tonight. Okay, so yeah, I can plug in the points and solve for K. Which point do you guys like? Either one's fine. If my equation's built correctly, it's going to go through both of those points, so I can use either. Do you guys prefer 5-4 or 3-3?
3-3.
Perfect. So my y value is going to be 3. My x value is going to be 3. And do a very small amount of solving. 3 minus 1 is 2. What's log base 2 of 2?
1.
1. Nice. And and so K is equal to 2. So what's my final answer?
f of x is equal to log base 2 x minus 1 plus 2.
Perfect. Fold that out. Since we're getting close to the final, box my answer. Yeah. And that's generally how we do these problems. Identify my vertical asymptote. That's going to tell me my horizontal shift. And then solve for my K by plugging in. If for some reason there is a vertical reflection, so my graph is flipped like this, the small adjustment you'll have to make is this would be a negative log. And then the process is exactly the same as well. Yeah, good answer, Austin. We can do either point. If you did 5-4, your process is slightly harder because you have a log that's not 1, it's 2, so it's not super difficult. But you can plug any point. In fact, there is another key point on this graph as well that would have been even easier to plug in. Right here, we have 2, 2. But whatever, as long as you're identifying an actual point on your graph and you built your logarithmic equation correct in that first step, point doesn't matter. You'll get the same K. Yeah, good question. Okay, I don't think I'm going to go into the next section today. As you can maybe see, it's only 2 slides. And sure, it's solving log equations, which isn't the most fun thing in the world, but it's not going to take the full class period. So probably what Monday will look like is we'll finish these 2 types of questions. We'll do an in-class review that maybe you won't be able to finish, but then you can work on it on your own if you want to, or work with your group later on. Then I'll probably post another in-class review on Wednesday just to give us the extra practice. The course captain gave me videos for the out-of-class review that he made, and those are generally pretty helpful. The out-of-class reviews, there are some questions that aren't on the exam, and there's probably more questions than you'll actually see on the exam, but it's pretty helpful. It's pretty close to the final exam, where then class reviews are going to be made by me, and they're going to be made after I've written your final or adjusted your final. There's some rules I have to follow, but they're going to be made by me after I slightly adjust your final. What else? I guess since we're in the home stretch, definitely make sure you're checking your grades. I believe I've dropped, if I haven't done so already, I will do in the near future. I believe I've dropped the lowest 2 homework scores, the lowest 2 in-class assignments. I might do more than that. Like, for example, if you do your FCQs, and let's say that we'll set a number of 80%. So if 80% of you guys do an FCQ, I can check the percentage response. Then I'll drop another homework assignment. So I'll drop 3. And even more like relaxation on the homework assignments. The last homework assignment kind of has some stuff we're not going to do, or maybe we didn't have enough time to spend on. So that is optional. If you do it, I replace your lowest homework score with that score. But if you don't do it, or if you have a really good homework scores, it's not going to affect your grade negatively at all if you just don't do it. So yeah, I think that's it. Before I put you in your groups, just to double check,